Many times, harmonic motion problems take the form of word problems. Here are some examples. A Ferris wheel has a radius of 10 meters and the bottom of the wheel passes 1 meter above the ground. If the Ferris wheel makes one complete revolution every 20 seconds, find an equation that gives the height above the ground of a person on the Ferris wheel as a function of time. So with a question like this, I think it's easier to see it visually. So let's draw a picture and see what it looks like. So we know we have a Ferris wheel, some circle above the ground, and it's above the ground about 1 meter. We also know that it has a radius of 10 meters. We also know that it takes 20 seconds to make one revolution. So I'm going to say it's going this direction, but it's just arbitrary. So these are the facts I know about this Ferris wheel. But I also can look at this and think, this literally looks like the x-axis. And if this circle was down in the middle of it, cutting it in half, it almost looked like it was starting like a sine graph, starting in the middle. But it looks like it's been shifted up 10 units because of the radius, plus 1 more because of how high it is off the ground. So because it's been shifted up, and because it's a Ferris wheel that has a neutral starting point, I'm thinking sine to make this function here. So y equals a sine of omega times t minus b plus d. So this is the equation for a shifted harmonic. Will I need everything here? Maybe not, but let's see what I need and disregard what I don't need. I can see that this graph has been shifted up. So I can see that I'm probably going to need d because that is a vertical shift, but I don't really think it's moving left or right, so I could probably disregard b. But I will always need to find the amplitude and omega. So let's find what I need, a, omega, and d. Well, like I said, if it was cutting it right in half, then I would say it moved up 10 spots because of the radius of the circle, 10. But it's also been moved up 1 more because of how high off the ground it is, 11. So I can look at this and think that my vertical shift d is 11. But I also see that the radius of the circle is 10, so 10 high, 10 down. So I could probably say that a equals 10, so it's an amplitude of 10. Now I have to find omega. Now I know that it takes 20 seconds to complete one revolution. So that's 1 period, 20 seconds. So I could say that the period is equal to 20, and you can find the period by doing 2 pi over omega. Well, here we can just solve for omega. I can multiply omega over and then divide the 20 over. So I'm going to end up getting omega equals pi over 10. And like I said, there's no horizontal shift, so I should feel pretty good. That's all I need. So plug everything into here and get my function. So y equals 10 sine of pi over 10 t, because we're using a function of time, so I'm going to use t, plus 11. And so there's my amplitude, my omega, and my vertical shift. So this would be the equation that models this question. Next, ordinary 110 volt household alternating current varies between a positive 155 volts to a negative 155 volts with a frequency of 60 hertz, which just means cycles per second. Find an equation that describes this variation in voltage. So the voltage is going from as high as 155 to down as low as negative 155. So there's typically like some starting point that's not zero because it's voltage. So I'm looking at this and I'm thinking that this is probably, since it has a point that's not on 0, I think this is cosine. So y equals A cosine of omega times t minus b plus d. Now, do I need everything here? Don't know, but we'll see. Well, I can see it varies from 155 to negative 155. So that's its amplitude, A. That one's pretty easy. Now, I can't see anything talking about moving up, moving down. It's electricity, so it wouldn't really make much sense to do that anyway. So nothing up or down, so I could probably disregard D, and nothing really left and right. Again, it wouldn't make much sense, so I could probably disregard B as well. So any phase shift and vertical shift can be just thrown away. I don't think we need any of it. But we do need omega. And the only information we have is 60 hertz, which is cycles per second, or the frequency. So the frequency is 60. I'm going to just drop the hertz because I just want the number itself. So 60, and I get 60 for the frequency by having omega over 2 pi. And here I can just solve for omega easily, multiply the 2 pi over, and I'm going to get 120 pi equals omega. So I got A, I got omega, and I'm disregarding phase shift and vertical shift. B and D just go away. So plug in what I know. Y equals 155 cosine of 120 pi times t. And there would be my equation for this problem here.